So excuse me, sir, your mic is mute, sir.
Discussed in last class, right? Suppose add m is being executed, right? Corresponding output for add m is 86. So if it is fetched from memory, and if it is here, then this 86 will be decoded by instruction decoder and machine cycle encoder, right? And then processor is going to understand whatever is the content of memory location 2400h, which is pointed by HL pair, will be fetched into the processor. It will be copied to temporary register, then accumulator plus temporary will be done, then it will be stored back in the accumulator. During this process it will go back to temporary, then from temporary to this, right? This one is the process. And why it is going back to temporary? In order to just reduce the number of micro instructions. Anyway, so up to this we discussed. Now next instruction is sub A over here. Draw thickness we need to decrease, and let us make it blue, right? So suppose sub A is the instruction, right? SUB A. Sub A, its opcode is 97. So what will happen whenever 97 is there in the accumulator, in the instruction register, this 97 opcode will be decoded, and processor is going to understand whatever is the content of accumulator, right? Suppose A is 55. So this 55 will be copied over here. Now A minus 55 will be done. So 55 minus 55 will be 0. So 0 will be stored back in the accumulator. And during this, 0 flag will be set to 1. Okay. Similarly, if we say go for instruction, say sub B or say sub E, what will happen? Sub E is the instruction over here, which is fetched by the processor. So how it will do? Whatever is the content of register E, right? Suppose here we have 44. So this 44 will be copied to temporary. Now A minus 44 will be done, and result will be stored back in the accumulator, right? And based on the result, flags are going to be affected. Next instruction, if you go by say this sub M, corresponding opcode is 96. You can see So corresponding opcode is 96. So if it is say 96 is the opcode, HL is say 2400, then what exactly it is going to do? HL will be outed from here, ALE will be made high. So this will be latch to external latch, and then it will point over here. Then read bar will be made low. This XX will be copied over here. Now A minus XX will be performed and result will be stored back in the accumulator. Okay, based on the result, flags are going to be affected. Similarly, we have SBB and ADC are there. Now suppose an instruction is executed like this: sub SBBC. So if sub C is the opcode, sub C is the instruction, then what exactly processor is going to do? C register content, suppose it is 33. So 33 will be copied over here, right? Now A minus 33 will be done, minus if carry flag. That's why this carry flag is right. This is in this direction. So carry flag will be subtracted whenever instruction SBBC is there. Sorry, SBBC is there. Then C will be copied over here. Now A minus C minus carry flag will be done, and result will be stored back over here. Similarly, suppose sub C is the instruction. What exactly it is going to do? Anyone quickly? Sub C is the instruction. Then what exactly processor will do? Hello?
Sir, A minus C.
A minus C will be done. Carry flag won't be there, right? Carry flag will not be taken from here. Now, if it is say SBBC, then A minus C, and whatever will be the carry flag, whether it is 1 or 0, it will be subtracted like this. Then result will be stored back. Okay. Similarly, SBBM is also there. SBBM is also there, right? Next, we have ACI byte. ADI byte is there. ADI stands for add immediate byte to the accumulator. It is a 2-byte instruction. It is a 2-byte instruction. In this case, what will happen? A plus byte plus carry flag will be there. Similarly, SBI byte. So A minus byte minus carry flag will be there. Okay. Hello. Is it okay?
Yes, sir.
Now we go for double add, right? So we have how many instructions? 1, 2, 3, 4 instructions are there. Suppose DAD B is the instruction. Opcode is 09. So suppose DAD B is fetched and opcode 09 comes over here. What exactly processor is going to understand? DE is say, this is say 4, 5, this is 6, 7, this is 8, 9, this is 3, 0, this is 2, 7, this is 8, 8. DAD B, DAD B, it will add BC pair to HL pair, and result will be stored where? In HL pair. Okay. So how it will be done? Right. Logically, this HL and BC has to be added, no? Like this. First of all, L and C will be added, and result will be stored in L. Right. And if carry is generated, then H plus B will be added, and result will be stored in H. Hello.
Yes, sir.
It's going to be like this only. So how it will do? How processor will do this? It will copy C register where? Here in temporary. It will copy H register to accumulator. Then, L register to accumulator. Then L plus C will be done. Result will be stored back in the temporary. Then from here it will go back to L register. Okay. Then B will be copied to temporary. 4, 5 will be over here. H will be copied over here, which will be 2, 7, and it will be B. So H plus B will be done. Result will be stored back in the temporary H plus B. Then it will come back to H register. Is it not? Hello?
Yes, sir.
Now in this process, accumulator content should not be destroyed. Right? So what will happen? Whenever this DAD instruction comes, right, of course it is double byte addition, but it will add byte by byte. So lower byte of C register will be copied to this. Lower byte of HL register pair will be copied to accumulator. And before that, accumulator will be saved somewhere. Right? Otherwise it will be destroyed. Right? If you go through the timing diagram of this, all these instructions, then it will be clear. Right? Now, whenever this type of instruction is being executed, first of all, lower byte of the registers, 16-bit registers, will be copied to temporary and accumulator, and then result will be stored back in the L register. Right? And during this, if carry is generated, this will be marked over here, and when H higher order byte are added, that time if carry flag is there, then also it will be added. Okay. Similarly, we have DAD, D, DAD, H, DAD, SP. Right? DAD B, DAD D, DAD H, and DAD SP. Corresponding opcodes you can see here 0, 1, 2, 3, 9, 9, 9, 9. Okay. Hello.
Yes, sir.
Now we go for next instruction, INR. Right. Now I will take the example of say INR E. Right. So INR E opcode is 1C. So suppose INR E instruction comes over here. Right. E register content will be copied to temporary. Suppose E equal to say FF is there. E equal to FF is there. So E plus FF plus 1 will be made over here. So what will be the result? FF plus 1 is how much? Quickly. FF plus 1.
Sir, 1000.
Huh?
100, sir.
1 0 0 0 0 0 0 0. So it will be 1 0 0. So logically in this case, carry flag has to set to 1. Hello. and
Yes.
result will be 0 0, and this 0 0 will be stored back over here. Okay, but this carry flag is not set during INR instruction, right? It is unaffected whether carry is generated or not. Okay, now suppose accumulator content A is FFH. Now if you do INR A, how it will be done? Of course, accumulator will be copied to temporary. Then it will be A plus temporary will be done. Now A plus 1 will be done. And what will happen? 0 0 will be stored over here, but carry flag won't be set. Carry flag is not going to be affected. Right? Now, suppose A equal to 0 0. Now A equal to FFH. Right? And we have ADI 01H instruction over here. What exactly it is going to do? It is a 2-byte instruction, right? So it will be decoded, and then 01 will be fetched from memory and it will be stored over here. Now FF plus 01 will be done. Result is going to be how much? Hello? FF plus 01?
Sir, carry flag 1 and 0 0 in the result.
And it will be 0 0 and carry flag will be equal to 1. So this is the difference between INR A and ADI 01. Right. Based on this, we had one question also on quiz, in quiz, right? INRL wala example tha na ji?
Yes, sir.
Right. We can use it till FFH, provided we don't have any instruction like DA, in the program. Otherwise, it may affect this, because whenever we are doing INRL, it will be done over here, right? And auxiliary carry may set. And due to that, if DA instruction is right, you have to use properly DA instruction, then only, right? So this way one question was framed, and I do not know how many of you answered that one correctly. Oh yeah. Next, this INRM is another very important instruction. This is opcode is 3-4. So if I do say INRM opcode is here, HL is say 2400. What a processor will do? Right. It will read the content of 2400 first, which is XX, will be copied over here. Right. Then XX plus 1 will be done, and result will be copied to temporary. Then again HL will be outed. It will point to this, and then XX plus 1 will be outed from here, and right bar will be made low, so XX plus 1 will be stored over here. Hello?
Yes, sir.
Right. So in this, what is happening? First of all, processor is reading opcode, then it is reading data from memory, it is incrementing that data, then it is storing back the incremented data onto the memory location. Right. It is a 1-byte instruction. Right. It is an example of indirect addressing, because data is pointed by a register pair. Right. Data is having address in the register pair, so indirect addressing. It reads the memory, it writes onto the memory. So both read and write operations are there. Next, if you come to this INX, INX SP is also there. DCX SP is also there, but we never use this because normally stack pointer is decremented automatically 2 times whenever we do pop instruction, push instruction, and it is incremented. It is incremented 2 times whenever we pop the 2 byte data from stack, top of the stack, to the register pair, right? So now let us go for these instructions. How it will be done? Suppose INX B is the instruction. BC is 24FF, right? So INX B is the opcode. So what exactly processor is going to do? Processor is going to increment this register pair. So how it will do? Hello? How INX B will be performed inside the processor? Hello?
Yes, sir.
How INX B will be performed in the inside the processor? Right. If it comes to say this 24FF will be copied over here, and it will be incremented here itself. So this will be 0, 0, and this will be 2, 5, and it will be stored back over here. During this, ALU is not involved, so flags are not affected. Okay. Hello.
Yes, sir.
Now suppose we have put a 16-bit count in a register pair like this: LXI D2430, 16-bit count. So how it will be decremented? It will become 242F, 242. Let us make it little less. 2401. We have this count. 2401. This much is this 16-bit count. Now, if we decrement this one by 1, it will become 2400. Then it will become 23FF. Then it will become 23FE. This way it will decrement, right? Then it will become 2301, right? 2300, 22FF. This way it will decrement, right? So when we will know that both are 0, 0, how we will understand, right? So let us do this. If we use this instruction DCXD, right, move A comma E, ORA D, J and Z, loop will be here. Hello?
Yes, sir.
Is this point is clear to you?
Yes, sir.
Why we are doing this? For checking DE register pair has become 0, 0, 0, 0 or not. Right? So with each decrement, DE pair will be decremented, right? E will be copied to temporary accumulator. Then ORA D will be done. So D will be copied to over here, and A odd with D, right? So flags are going to be affected, and result will be stored back in the accumulator. So this we keep on doing till both register content becomes 0. Okay, because with DCXD, flags are not affected.
Sir, but this will affect only D, no, sir, not E. ORA D.
ORA D, we are copying register E to accumulator, no?
Yes, sir.
So both we are checking, no? LXI D 2400H, DCX D, right? Move A comma E, ORA D. So basically we are doing that. We are ORing D with A. No, D with E. No?
Yes, sir, understood, sir.
Right. This instruction we discussed so many times, DA in detail. Of course, in laboratory also, right? This DA instruction has been discussed so many times. Right. Whenever DA instruction is there, right? Suppose DA instruction is here, DAA. What exactly processor is going to do? It will check the each nibble X and Y of the accumulator. It will check lower nibble Y and auxiliary carry flag of the flag register. If Y is greater than 9, or auxiliary carry flag is 1, then it will add 6 to Y. Then it will check higher nibble, right? If X is greater than 9 or carry flag is there equal to 1, then it will add 6 to upper nibble, right? And during this, if again the result becomes more than 9, any nibble of the result becomes more than 9, then it adds 6 to that nibble. Okay, this is used for adjusting the accumulator to its equivalent BCD value whenever we are doing the BCD addition. We discussed this one so many times, so no need to go in detail, right? Then CMA stands for complement accumulator, right? Complement accumulator. So suppose A is FFH, right? CMA is the instruction, right? A will be, right? Then CMA, so A bar will be produced over here, it will be 0, 0. Result will be stored back to accumulator, right? 0 flag will be set to 1, right? If suppose A is accumulator is AAH 10 10 10 10H, and CMA is the instruction. What exactly it is going to do? It will 0 1 0 1 0 1 0 1. This will be the result, and it will be stored back in the accumulator. So it will be 5 5, and based on this, flags are going to be affected. Number of ones are not changing, so it's right. Suppose A is this. A is 1 0 0 0 0 0 0. So right now it is 8 0. If CMA is the instruction, then what will happen? It will be 7F, and 7F will be stored over here. How 7F? This will be 0 1 1, right? Now number of ones are odd, so accordingly parity flag will be set or reset, right? And CMA is an example of implied addressing. Right, implied addressing means where exactly the data is mentioned. CMA valid for accumulator only, so data will be always in the accumulator. So it is implied that data will be always in the accumulator. So in FAF1, what are the instructions we have? LDA 9H, this type of instruction was there. Add BH, add CH, sub DH, out, halt. So this is example of direct addressing because address is given directly over here. This is also example of direct addressing, right? Because byte will be added from BH location. Byte will be added from CH location, right? DH location. And out is implied addressing, no? Because accumulator content will be outed to where? So one question was there. How, right? What are the different? In quiz it was there, no? So implied and direct addressing modes were available in SAF1 system. Simply now here we have complement carry, right? If carry flag is equal to 0, then it will be become 1 in flag register. If carry flag is 1, then it will become 0 with complement carry. STC, whether it is carry flag 1 or 0, finally carry flag will be equal to 1, set carry. Add immediate byte with carry, sub immediate byte with borrow or carry. See, in all INR or DCR instruction, except carry flag, all flags except carry may be affected. So carry flag is not affected during INR and DCR. It is written over here. Where? INR किधर गया? You can see a double star is there. In triple star, only carry flag is affected. You can see only carry flag is affected. Of course, now no need to explain all these things. Logical operation will be performed between accumulator and the operand register. ANA A, ANA B, ANA C, ANA D, ANA E, ANA H, ANA L, ANA M. In this case, accumulator will be ended with memory content of memory location pointed by HL here, and result will be stored in accumulator. Right. Similarly, ORAM, A or with MHL, and it will be stored over here. Then XRA, A XOR with MHL, and result will be stored in accumulator. Right. All flags may be affected, it is written over here. But during this AND or XOR operation, carry is not going to be affected. Carry is not going to be affected. Now you can see compare instruction. Very, very important instruction while doing the sorting and analyzing the data. Right? If you do, say, compare A, CMP A, how it will be done inside the processor? CMP A. So accumulator content will be copied to accumulator temporary. Then A minus temporary will be done. What will the result? Hello? What will the result?
Sir, carry flags will change.
Result will be 0, 0. Compare A, if it is the instruction, right? A will be copied to temporary, A minus temporary will be performed, and result will be 0, 0. So 0 flag will be set to 1, but this result is not going to be stored back in the accumulator. Okay. Hello?
Yes, sir.
Now, if you take an example of this, compare B. If compare B is the instruction, what will happen? B register content will be copied over here. Now A minus B will be performed. And based on the result, flags are going to be affected. But this A minus B result is not going to be stored back over here. In case of sub B, SUB B, what will happen? B register content will be copied over here. A minus B will be performed. Flags are going to be affected and result is stored back in the accumulator. But in compare instruction, again subtraction is performed. But result is not stored back in the accumulator. Hello?
Yes, sir.
And how flags are affected? Suppose A is greater than B. Then 0 flag, A minus B, result is going to be non-zero, no? So 0 flag will be 0. Now if A is greater than B, carry flag will be 0. Now if A is less than B, 0 flag will be what? It will be 0 because A minus B is going to be non-zero. Now carry flag is going to be 1 because A is less than B. Result is going to be negative. So carry flag will be generated. Now if A equal to B, what will happen? A minus B will be 0, 0. So 0 flag will be set to 1 while carry flag is not going to set. So it will be 0. Right. So using compare instruction, you can compare the 2 bytes, right? Whether it is, which one is greater. Of course, this comparison will be done between accumulator and the register. Now, suppose we are writing this CMP M and accumulator is say 4, 5. What exactly processor is going to do? It will bring the data from the memory location pointed by HL pair. So 2400, suppose it is here. 2400, and this is our HL. HL is pointing to this location, and here we have say 37. So now this 37 and accumulator content 4, 5 will be compared. So 4, 5 minus 37 will be performed. Now result is going to be non-zero. So carry flag is not going to be set because 45 is more than 37. 0 flag is not going to be set. Right. So from this we can conclude that if carry flag is 0, it means accumulator content is more than this content. Now suppose we do this 2401. Here we have 4, 5. Right. Now if you do say this LXIH 2400H, right? Move A comma M. What will the accumulator content after this? Anyone quickly? Hello?
Sir, 4-5. No, sir, sorry, 3-7, 3-7.
It will be 3-7. Right. Now I am doing INXH. Now if you do say compare M, what will happen? 45 will be copied over here. Then 37 minus 45 will be done. So what will happen? Hello? 37 minus 45 will be done, no?
Yes, sir.
So what will happen?
Sir, the zero flag will be 0 and the carry flag will also be 0, sir.
Why? Why carry flag will be 0? 37 is greater than 45.
No, sir, carry flag will not be 0.
Will not be 0. So it will be what? It will
Sir,
be, don't care. अरे अभी थोड़ी देर पहले बोला ना जी, if A is greater than register, then zero flag, carry flag both will be 0. If A is less than register, then carry flag will be 1 and zero flag will be 0. If A equal to register, then both flags will be, zero flag will be 1 and carry flag will be 0. यही बोला था ना हमने. So 37 is greater than 45. So carry flag, 37 is less than 45 now. So carry flag will be set. So JC 2401 is greater. Is it not?
yes, sir.
Right. और JNC कब लिख सकते हैं हम लोग? JNC 2400 is lesser than 2401. Right. Similarly, we can compare. We can do compare byte, right? So A minus byte will be done. If A equal to byte, what will happen? Zero flag will be equal to 1. Carry flag will be 0. If A greater than byte, zero flag will be 0. Carry flag will be 0. A less than byte, right? Zero flag will be 0. Carry flag will be 1. CMP byte. Now this instruction is very, very important one. ANI byte. हेलो, अरे हम 9 बजे से क्लास में हैं भाई, 9 बजे से क्लास में हैं. हाँ, अरे क्लास में है अभी तो हम पढ़े आपका. नहीं, ठीक है. Okay, so this ANI byte is very, very important instruction. This is used for, it's up to you for what purpose you are using, right? But mainly we use this one for checking any bit is 1 or not, right? Suppose in memory location 2400H, we have some byte, say 01001010, like this. This one is the byte. Now it has got how many bits? D0, D1, D2, D3, D4, D5, D6, D7 bits are there. These many bits are there. If any bit is 1 or not, that we can check with the help of ANI byte. Let us do it. How it will be done. So for that, let us put a table over here. Insert table 1, 2, 3, 4, 5, 6, 7, 8 bit. इसको नीचे कर ले यहाँ पे. So this is D0, this is D1, this is D2, this is D3, D4, D5, D6, D7, right? Suppose at say 2400H we have some byte 4A, right? 4A. Now if you do LDA 2400H and suppose this one is the accumulator, what will the accumulator content? This will be 0, 1, 0, 0, 4. No?
Yes, sir.
Then it will be 1, 0, 1, 0. Now if you want to check whether D0 bit is 1 or not, D0 bit is 1 or not, then what we are supposed to do? If you do say ANI 01H, ANI 01H, what exactly it is going to do? It will AND accumulator. Accumulator content is nothing but 0, 1, 0, 0, 1, 0, 0, 0. So this 0, 1 will be copied to temporary register. Now A minus temporary will be done. So let us say this is our temporary register now. Sorry. Right. Temporary register will be what? 0, 0, 0, 0, 0, 0, 0, 1. Right. Now this will be our result. Result will be what? 0 ANDed with 0 will be what? 0, 1 ANDed with 0. क्या होगा result? 0, 0 ANDed with 0, 0 ANDed with 0, 1 ANDed with 0, 0 ANDed with 0. So actually we are checking this D0 bit. Now ANI 01H means A will be equal to, in this case, what will be accumulator now? It will be this 0, 0, 0, 0, 0, 0, 0, 0. So in this case, 0 flag will be set. And we will continue, we'll conclude what? D0 bit is 0. Now suppose if you do ANI 20H, 02H. So 02 means it will be 1 and this will be 0. So now result is going to be what? This. So 0 flag is not going to be 0. In this case, what we are going to conclude?
Sir,
That-
zero flag will become 1.
How it will become 1? ANI 02H we are doing. Account content is what? 0100 1010. Right? 02 is 00000010. So if we add this with this, these two, it will be 0. 1 into 1, 1 ANDed with 1, result will be 1, no? 0
Yes,
ANDed.
sir.
So in this case, 0 flag means accumulator content is not 0. So 0 flag won't be set, and we will conclude what? D1 bit is
1, sir.
right.
Yes, sir.
Now, another example I am taking.
Sir, excuse me, sir.
Yes.
Sir, could we continue next class, sir? We have a class now, actually.
Of course, we will continue in next class. Now, and I'll just finish it within, say, 1 minute, right? So if you do say LDA 2400H, and if you do say ANI 0FH, what will be accumulator content?
Sir, 0, 0.
Huh?
No, sir, 0A, sir.
Accumulator content will be 0A. And if you do say LDA 2401 00H, and if you do ANI F0, what will be accumulator content?
Sir, 40.
40. Now, right. So this is used for isolating the nibbles. Okay, we will continue in next class, not a problem. Right. Tomorrow and on Friday also we have. So by that time we will finish all the instruction, and today I will discuss with HOD sir also. And okay.
Excuse me, sir.
Yes.